All right, good day, everyone. This is Jason Straight with the Cloud Pass Virtual Group. Our presenter today is Jason Horner, back again after a couple weeks. He's going to be presenting today real-world data movement and orchestration patterns using Azure Data Factory V2. Before I hand things over to him, though, I do have a few announcements I want to run through. So the first is, if I can learn how to click the next slide. There we go. The first is this virtual group is sponsored by Microsoft Azure. Microsoft Azure helps us build things and put them up in the cloud itself. And then their support helps make sure that we can keep doing all of these webcasts. If you are not yet a member of this virtual group, I do recommend going out and becoming a member. You can do that at cloud.pos.org. Go out there, log in, subscribe to the group, and once you've done that, you'll get the newsletter that comes out usually about once a week, has all the upcoming sessions in it. Right now, we've got a number of sessions that are planned, and speaking of those, we've got 12 that are currently scheduled out into the future. Some going all the way out to July, so I try to do 2 per week. We got another coming up this week on Thursday with James Sarah coming back again to present to us on whether you should move your database to the cloud or not. So lots of different opportunities to learn about building up data platforms in the cloud. I am, of course, always looking for additional speakers. There are 52 weeks a year, and I try to do 2 a week, kick out a couple holidays where we don't do presentations, so that's about 100 different presenters. So if you are interested in presenting, do recommend just reaching out to me at cloud@pass.org, or if you want to, you can go to the call for speakers link at the cloud.pass.org website and fill that out and get onto the schedule as well. Coming up this fall is the Pass Summit 2020. The call for speakers for that is now currently open. That's open now through April 23rd. You can submit up to 3 different sessions, and I highly recommend going out and doing so. If you've got an idea or something that you figured out that you'd like to share with other folks, Pass Summit's a great venue for doing that. Besides this virtual group, you can do it here first. Beyond that, if you are planning to go to the summit and you haven't registered yet, don't think a lot of people have yet because it's still a few months out. But if you haven't and you want to get a $150 discount, you can do that using our virtual groups discount code, which is there on the screen. And I'll keep showing that every session so that folks, so if you do miss it, you can catch it in the next session or on the recording of this session. Coming up on April 9th, is the Secure Data Storage Pass Marathon. It's an opportunity to learn a bunch of data storage, different technologies and things that apply to compliance, so it's something to go check out. This virtual group is part of a number of virtual groups that Pass helps to support. They focus on different areas such as data science or database administration, or on different languages to help folks that may not be native English speakers get a better understanding through the language that you generally speak. So there's global Chinese, global Spanish, global Hebrew, lots of different virtual groups out there. So go ahead and check them out. Throughout the session, if you do have any questions, please type them into the question panel. As you type them in, we'll store them up, and then at the end, Jason and myself will go through those and give him an opportunity to answer your questions. Additionally, Jason's going to have a few questions for you as the audience. So if you could open up a browser and go to slido.com and then type in meeting ID 16682. He does have this on his slides as well, but that'll give him a chance to ask a few questions that he has for the audience. And with that, I'm going to make Jason the presenter here. So his session today, real world data movement orchestration patterns using Data Factory V2. So let's see here. Let me make Jason the presenter. All right, Jason, you are now the presenter, and I'm going to turn my camera up because nobody needs to see my mug anymore.
So hello, everybody. I want to start with the poll, so hopefully you guys had a chance to sign into that, and I want to see what folks are thinking here. So let's give this a moment to pop up. All right, so a lot of beginners. This is interesting. Okay, this is good though. This is helpful. I'm gonna give it a few more seconds here to validate. Oop, we're changing. Oh, Only 7? There's 65 people on. 73. All right. I'll give it a few more seconds. I'll leave this open, but definitely keep it open. I've got 2 more questions that I'm going to hit at various points in the session. So we'll run into the session. Wow, it's really shifting. Okay, cool. Alrighty, so let's see. Let's do from beginning. All right, so we're doing real world data movement and orchestration patterns using Azure Data Factory. I'm your host, Jason Horner. I'm wearing my Cedar Point shirt. It's the best place ever. And I have my COVID hairstyle. So everything's rocking and rolling in my quarantine life. I do stuff, I know stuff. Always happy to answer questions on Azure Data Factory, Azure Databricks, Data Lake, those kind of things. In case you didn't attend my last presentation about a couple of weeks ago, I did a session on Azure Data Lake design patterns. The video's up on YouTube, so go ahead and check it out. Feel free to connect to me on LinkedIn, follow me on Twitter, and yeah, just hope you guys enjoy this session. So let's go. So Azure Data Factory. So what we're going to do today is we're going to start with just a high-level overview of Azure Data Factory for those of you guys who are completely new to it. Then we'll go into some design patterns, and then we'll go into some operationalization of Azure Data Factory. So things like CI/CD, DevOps, and monitoring. We may run a little bit late, so hopefully that's okay, but we'll see. There's a lot of content to cover, and I may have to skip through some things. So basically, Azure Data Factory is used to orchestrate and move data across various systems. So in a traditional data warehouse architecture, I have many source systems, right? Those could be Azure SQL databases. They could be other sources, non-structured data lake source, third parties, platform as a service offerings, those kind of things. And the idea is that I need to get the data out of those systems, integrate them into a data lake or a data warehouse, provide them perhaps in like Power BI for reporting or Azure Analysis Services for a BI semantic model. And I'm going to use Azure Data Factory to orchestrate that. So a lot of people used to say that ADF is really like SSIS in the cloud, which isn't quite accurate. And we'll talk a little bit about why that is. But that situation is pretty dynamic. It's changed a lot. I've been speaking with it speaking on it and using it for probably about 3 or 4 years, and it's undergone quite a significant amount of changes. With that being said, there's really not a lot of concepts inside of Azure Data Factory. It's a fairly simple service. You have pipelines, you have activities, which are the doers, right? You have data sets, which are the shape of our data, whether that's structured or unstructured, link services, which are our connection strings. You have data flows, which is a kind of an advanced feature for doing transformation at scale using Spark technology. You have templates, which is a way to take kind of repeated patterns and deploy them to kind of give you a quick start. Triggers are how you control operations. So if I want to schedule a pipeline for execution, I could use a trigger to do that. And the integration runtime is the compute that actually executes the queries for you. So if I have to connect to an on-premises SQL server, I'm going to use an integration runtime to make that connection between the data source, which is my on-prem SQL server, and my data sink, which would be perhaps my Azure Data Lake, right? So it brokers a connection in a secure manner. And we'll talk more about each of these as we go forward. So let's talk a little bit about pipelines. So what is a pipeline? A pipeline is basically a workflow unit. It's a logical grouping of one or more activities. It's very similar in SSIS world to the concept of a package, okay? Activities can be chained together with precedence constraints. So here you see 3 activities chained together with success precedence constraints. I also have failure, I have completion, I have skipped, I have different types of precedence constraints. The one kind of downer about SSIS and, about Azure Data Factory and precedence constraints is there's no ability to do conditional precedence constraints. So I can't do an either or pattern. If you go to the user voice for Data Factory, there's a feedback item that Megan Longoria left there, and I would highly recommend you upvote that because that functionality unblocks a lot of more complex orchestration things. So when I think about these pipelines, this is where I start. I start with a pipeline. I build my data transformation in this pipeline. Okay, so it's my container. I have a couple different options. I can debug them, I can execute them manually, or I can set up a trigger. Again, a trigger is just a schedule. And then I can monitor these pipelines. So Azure Data Factory provides a management dashboard where I can look and watch the package or the pipeline run. It provides a bunch of additional kind of metadata associated with that. I can also set up alerts and metrics, which we'll talk about towards the end of the session, okay? Activities. So activities are kind of the doers. They're the most important things, and they're grouped in the UI into these kind of different buckets. So the heavy hitters, or the ones you're going to use most frequently, are probably copy data, which basically takes data from a source to a sink, right? So a source could be any type of destination. It could be a file share. It could be a data lake. It could be a third-party SaaS service, on-prem or cloud-based database services, right? And then putting them into a sink, which could be the same things. The data flow allows you to execute a data flow. A data flow is a way to do data transformation at scale, like I said earlier, and we'll talk more about that. I've got a couple slides on that. Then when I'm orchestrating work, I often need to do things like iterate or conditionally execute something. So I may only want to process a copy routine if a file is present, right? So I could use an if condition for that. I may need to get a list of files that I need to copy over. I could use a for each for that, or any kind of list. The filter is kind of an interesting one. Filter is typically used to apply a predicate. So there's some activities that return kind of a data set, like the get metadata activity can return a data set, and the filter activity can be used to put a predicate on that to only pass through the ones that meet that condition. The metadata entries. The until just provides another looping construct, pretty basic. General activity, so to get metadata, that's an overlooked one. If you're not familiar with it, I don't have time to get into it a whole lot today, but definitely look at that. Especially in SSIS, if you've had problems with metadata becoming out of sync and causing your package to fail. For example, somebody adds a new column to a file, or somebody adds a new column to a database, or removes a column, or changes the labeling or the ordering. The get metadata activity allows you to go query that data store and figure out what the columns are and compare it versus what you're expecting and take action based on that result. So if it's not the same, I could abort, or I could send an error notification, or try to recover from it. Then the two other tasks that are pretty prominent are the lookup and stored procedure. They do kind of similar things, but with a different purpose. So one of the key things to keep in mind about the lookup activity is it's not at all like the lookup in SSIS. The lookup in SSIS basically says, for each row in this data flow, I'm gonna try to look up a row or make some kind of calculation, right? The lookup activity in ADF basically connects against a relational data store and executes a query that you can put parameters into it and returns a result set. That result set can be a singleton, meaning a single row, or it can return many rows. Okay, so it's our primary way of driving dynamic behavior into our package at runtime, or our pipeline into runtime. A stored procedure is basically a way to execute compute on the SQL server. The interesting limitation of the stored procedure activity is that it can't return any result sets. So you can have result sets in your stored procedure, but they're not going back. When you execute that stored procedure, it executes it. It does not return result sets back. It does not return output parameters. None of that capability that you get inside of SSIS is currently exposed in Azure Data Factory. There is a feedback item on that stored procedure activity to support those constructs. So if that's something that you think would be useful, definitely go check that out. Then we have some various other tasks. The ability to call an Azure function, for example, execute pipeline, that's very similar to our execute package. This execute SSIS package would be how I would, if I needed to use the capability of ADF to execute SSIS packages, I have this thing, and that capability requires what's called a SSIS integration runtime, which basically gives you a connection to a metadata catalog where you can store your package metadata, as well as dynamically spins up a execution environment for your SSIS package. You can do things that are kind of crazy with that, like you can inject custom installs into that. So if I need to use a third-party component like a Cozy Rock or a SentryOne, or any of those types of third-party Kingsway components, I can execute that and make sure that environment has its own stuff. Other things like, the Attunity CDC components, all those kind of things are supported in that manner. And then relatively newer addition is the set and append variable task. This is to work with variables, and we'll talk a little bit, but the two dynamic constructs you have in Azure Data Factory are pipeline parameters, right, which allow you to basically inject a value at runtime to configure the pipeline. And then variables, and now when you use a pipeline parameter, you can't change that value. It's set for the duration of that execution. However, variables can change. They can mutate throughout execution. So variables become very useful when I'm building dynamic pipelines. And then a real recent activity is this validation activity. This activity attempts to solve the problem of I'm running this pipeline and I'm looking for a file and it's not there yet. I don't want the activity to fail. I want it to wait a few minutes. Maybe I want it to wait 20 minutes for the file to show up. The validation activity, you can set a timeout on it. You set the path that you're looking for the file to show up and a minimum size on it, and it'll basically execute success when that assertion is made true, or it'll fail if it never shows up or it times out. And then you can do logic on your downstream processing. So definitely, I would say even if you're familiar with Azure Data Factory, this get metadata activity and the validation activity are two very important activities for building bulletproof pipelines. Then you have this concept of being able to run compute. So not a lot of folks are using uSQL anymore, but it is still supported. You can execute Databricks via a notebook, a Python script directly, or a jar file, and then any of the HD Insight tasks as well. So these are ways to basically say, okay, I've moved some data into my data lake. Now I want to execute a Databricks notebook to do some data cleansing, or I want to execute a pig job to do some extract, transform, and load, right? Or map reduce, any of these things, or a Hive query. So I can do all these things from these activities. I can also use the batch service. So that's the way if I want to set up an environment to run custom executables or executables across a data set. So kind of an example of where I've used this in the past is we had a county departmental GIS system, and they had a lot of shape files that they needed to generate and process. So we set up the batch service, and the benefit of the batch service is it scales up. So I could basically build a cluster of like 10 different servers with this custom shapefile processing utility on it, and then I could run all that effort in parallel. So instead of this process taking 2 days over the weekend, we got it down into 90 minutes by running it concurrently. And all it did was basically call their ArcGIS server, extract out the current shape files for different points of interest, right? So that's kind of a cool thing. You can also do this to do other activities like running file system commands on a local machine, and then you have access to machine learning activities. So if you're working with the Azure machine learning, there's ways to update the resources and do batch execution. But copy data is really the one we want to double click on today. It's very important to understand this. This is kind of foundational to everything that you're going to do. You'll note here that from this copy activity, we've got a couple properties tabs, right? So the source tab is basically defining our source data set. And keep in mind that the data set is the shape of the data. So that represents a table. Like here I'm using sales.lt.customer table. That data set is also linked to a linked service. So there's a relationship between the source has a relationship to a single data set. A data set can relate to a single linked service. Multiple data sets can point to the same linked service. So it's kind of important to understand that. You'll notice here that in the copy data source for the Azure SQL database, I can query it via table, just say, give me the entire table results. I can create a custom SQL query, or I can call a stored procedure. So the stored procedure, if it returns results sets, it'll come into this copy activity. That's not the same as that stored procedure activity that I talked about earlier. That's an actual standalone activity. That's more like an exec SQL task in SSIS, where it's just going to execute the stored procedure, not return any results back. But these results that come back from the stored procedure, you can't do any processing with them currently in Azure Data Factory from here. Basically, what you can do is store them in your sink. And then you'll notice here we have some examples. So I have a table name here. I've got a database name. I can run a pre-copy script. So let's say I'm doing a staging pattern where I need to truncate the table before I load it. I can run that truncate statement here. I could also call a stored procedure from here. Very important to set the timeouts and the batch size. So here I'm going to do it in 10,000 increments of 10,000 rows at a time. So if my source has 100,000 rows, this copy activity is going to do 10 different batches, right? So it's going to commit those in 10,000 row batches. Okay. Let's see, what else do we have? So what the copy data activity does, as I mentioned, is we have a source, we have a sink, and then the integration runtime is the actual compute that it runs on. So let's say, for example, I'm pulling it from an on-prem Oracle server, for example, because I'm really crazy. I don't know. I'm going to have what's called a self-hosted integration runtime that's going to be in my on-premise environment. It's going to have network connectivity to that Oracle server, and it's going to handle the column mapping. It's going to handle the compression and decompression if I'm specifying that. So if I'm pulling the data from Oracle and I'm going to dump it out to a compressed CSV file, it'll handle that. It'll also handle the serialization, deserialization, so any data type conversions that it needs to do, any of the compute, and then it moves it over to the sink. So the important concept to understand is that when I'm executing a pipeline, the data isn't flowing from the source system into my data factory and then into my sink. It's going directly from that source to the sink via an integration runtime. And that there's several different types of integration runtimes, and we'll talk more about that in a little bit, but it's a key concept to understand. It's also important to understand these performance metrics. Now, this is an old slide. I'm not sure, 100% sure that these metrics are still accurate. They were as of 2 years ago. They haven't updated this recently, but you'll notice here that there's a top end performance that you can get out of pulling data from an on-premise SQL server into Azure Data Lake Gen 1 or Gen 2, right? And so it maxes out around 7 megabits per second. That's a service limitation. There's ways to kind of get around that by calling multiple pipelines concurrently, but just note that other ways, like if I'm copying data from file systems, so if I BCP'd a bunch of data out from SQL Server and wanted to just copy it into my data lake, if I set up 4 gateway nodes here, I can effectively linearly increase my throughput. So I can go from 195 to 505 to go to blob storage. If I wanted to go to Data Lake Gen 2, I can go from 192 to 510. So it's important to make sure you have the right number of integration runtime gateway nodes when you're processing big data, okay? So that's probably all I want to say about performance. So data flows. So what's a data flow? What's the difference between a data flow and a pipeline? So a pipeline can host one or more data flows. As you can see with that copy activity, I can move data from source to sink, but I don't have a lot of transformation capabilities in that. So the mapping data flow here basically gives me the ability to join data sets from various source systems, perform transformations like filtering, joining, all the kind of things that I can, a lot of the things that I can do in an SSIS data flow, I can do in a mapping data flow. The key difference with a mapping data flow is that it's going to fire up behind the scenes a Spark cluster for you, actually a Databricks cluster, and that may not be appropriate. If you're just moving, let's say 100 rows, it might take, and the time's gotten a lot better, but it may take a few minutes to spin this up. So maybe that doesn't kill you, right? But you're now spinning up this big Databricks cluster to move the data through here. So unless you're doing some serious transformation heavy lifting or you're processing a lot of data, you may not want to use these mapping data flows. They're very powerful, they're very complex, and the capabilities that they give you have really kind of come along in the 2 years that they've been out in general availability. So again, this is primarily for doing data transformation at scale. Now, the other type of data flow you can do is a wrangling data flow, and that's really meant kind of more for ad hoc purposes, at least right now. It allows you to do data prep work. So if you're a data scientist and you have access to a data lake and you want to, create kind of a custom built, like a curated data set to do a specific data science training exercise or any kind of, run some data science experiments on it, you could potentially use this wrangling data flow. It allows you to use the Power Query language, which is M, which is the same language that you use in Excel, get and transform data, or in Power BI to pull data. So you have a lot of those functions available. Not all the functions are currently supported because it is still in preview, And the limitation is right now, I believe it only supports CSV and Parquet. So the Parquet support is recently introduced in the last couple months, I believe, but that was a huge gap because a lot of people are using Parquet as their data lake storage of choice. And so without that, what you would have to do is run a Databricks activity to take the data. Say you get the data in JSON, you have to run a Databricks activity, convert the JSON data into CSV, and then use wrangling data flows to take and perform your Power Query on it. And it wasn't a great experience. So it's getting better. I expect this to be extremely powerful and a lot more useful once it gets closer to GA. The key thing that I see is Power Query gives me the ability to, in theory, like process Excel files, process XML files, things that Azure Data Factory doesn't handle natively with their copy activities. So this could unblock a lot of data connection scenarios as well. But the key purpose of this, or where they're targeting it, is at that data science or data wrangler kind of position, right? So, yeehaw, everybody, wrangle your data. I don't know. So just to compare these, right? So the purpose of mapping is to transform data, and wrangling is to prepare data or validate it, right? So wrangling is a great way to investigate my data at scale. It uses a Spark cluster or Databricks cluster as well, and it allows me to do that data profiling, okay? So as far as formats, this slide's a little out of date. It says CSV only, but it also supports Parquet. Mapping data flows support much more formats and connectors. The storage mechanism for wrangling data flow, I believe this is still correct. It supported Azure Blob Store, Data Lake Gen 1, Data Lake Gen 2, SQL, and SQL DW. And these are the Azure versions of those services. So it can't connect to APS. It can't connect to an on-prem SQL server, I don't think yet. The environment, so there's an expression language that's based roughly on the PySpark that you can do from inside of mapping data flow. And with with the wrangling data flow, you have the mashup editor. As I said, that code language for mapping data flows is a custom expression language, whereas the wrangling data flows use Power Query M. So mapping is a general availability, so it's fit for production use right now. Wrangling data flows is not quite fit for production use, I would say, and it's getting better, but not quite there yet. So data sets. So data sets are our views. They represent the shape of the data, right? So tables, files, folders, JSON documents, they can be used as inputs or outputs, so sources or sinks. And one of the key things, concepts that you need to understand is they support two types of schemas, implicit or explicit. So an explicit schema is where I basically connect to that data source, whether it's a file or a table, and it interrogates the schema and it creates that as the structure. So that if I go to run the pipeline again, if that structure doesn't match, it's going to return an error. If I do implicit mapping, it's basically allowing that schema to drift over time. It basically says, hey, whatever you give me on the source, as long as I can do a mapping to it on the destination or the sink, as long as I have a one-to-one mapping and the column ordering matches and the casing matches, it's going to wire it up for me, which is a huge advantage over SSIS, because with SSIS, it's very tightly bound to the metadata at design time, right? So if anybody's ever had an experience with an SSIS package that now has a bunch of yellow squigglies all over it because you changed a column order or somebody decided they were going to change the casing in a query and the pipeline metadata broke, that's not a problem with ADF, assuming you're using implicit schema mappings. So that opens up a lot of capability to make extremely dynamic Azure Data Factory pipelines, which we're going to go into towards the middle of the presentation. Link services. So those are our connection strings, very similar to connection managers in SSIS. They have connection information to the data sources. Now, it's important to note there's two types of link services. There's data store link services, which allow me to retrieve data from a store and move it with the copy activity. Then we have what's called a compute link service, and that's those activities that execute compute, like the Databricks activity, the HD Insight activity, the USQL activity. They all use compute link services. So that doesn't allow us to pull data back. It just allows us to execute compute. Okay, that doesn't mean I can't pull data out of Databricks, right? If I have data in a Databricks Hive table, I can connect with JDBC and pull the data using a data store link service. But if I'm going to execute a notebook, I don't have a way to stream those results back to a copy activity, for example, because I'm using a compute activity. I can get output parameters from notebooks, so I can do a little bit of magic there. But generally speaking, I'm not using that as a data transfer mechanism. So another kind of pattern that I see people do a lot is move the data into the raw zone of their data lake. And let's say it's a JSON file and you're going to prep it to load it in Synapse. So Synapse can't natively load JSON. So a pattern you could potentially use is put it in a Databricks notebook, rewrite the JSON out as a CSV or a Parquet file, and then load it into Synapse, which natively understands how to load Parquet and CSV, among other file formats. So that's a pattern you can use there. There's also better ways of loading Synapse that's out there. You can use the copy command, you can use polybase, or you can use bulk insert. So there's different options there, but that's another example of how to use these. So as far as data stores, all the Azure services you would expect. So things like Azure Data Explorer, Postgres, MySQL, Azure SQL Data Warehouse or Synapse, managed instances, right? Blob storage, all the different APIs, Cosmos with the various APIs. Then you've got your traditional databases. So it's important to note here that, for example, if I'm talking to an Azure SQL database, I actually need to use this Azure SQL database connector. If I'm talking managed instance, I need to use the managed instance connector. But there's also DB specific connectors, right? So you can see here I've got a SQL Server connector. If I'm talking to an on-premise SQL Server or a SQL Server that's hosted in an Azure VM, I want to use this SQL Server connection type. The reason is the credentials and the connection strings that it supports are different based on the connectors. An important thing to understand about linked services too, they're not symmetric in all cases. So for example, a good example of this is Presto. Presto is a big data query service where I can run queries at scale across big data sets. And I can execute a query against Presto and bring the results back, but I can't use Presto as a source, right? So most of the databases are symmetric, meaning that I can use them as a sink or a source. Some data sets can only be sources. As far as I know, there aren't any data sources that can only be sinks. But anyway, so you pretty much have sink and source or just sources. Then we have file type stores, right? So these can be things like cloud storage, like Google or S3, FTP servers, SFTP servers, text files, Parquet, various kind of things like that. The key thing is they all kind of have file or directory type semantics to them, right? And then if I need to connect to, like, let's say a custom database, or maybe I need a specific version of the Postgres driver, if I'm using a self-hosted integration runtime, I can install those ODBC drivers on that integration runtime and use this ODBC connection, right? Which is an important thing to note when I set up my integration runtime, my self-hosted ones. I need to make sure that I also install a supported version of the JRE if I want to work with the big data file formats, and any drivers that I need. Now, some of the drivers, like there's a built-in Postgres driver, and some of the other data providers have built-in drivers, but in certain cases, you're using a specific driver that you need to install that driver yourself. And then there's a REST activity. So if you have a RESTful API, you want to pull data back from that, you have a REST activity that kind of simplifies that. The one downer with the REST activity implementation right now is it doesn't natively support OAuth authentication. So if you have a long-lived OAuth token that you've generated, you can put that in your header and use that to authenticate to the REST service. But if you need to actually do the OAuth authentication at runtime, unless you manually go through that and maybe use like an Azure function or some other process, there's not a way in the connection itself to generate that, do that header authentication dance. So kind of a downfall of that, or shortcoming. And then any of the NoSQL stores, so Cassandra, Couchbase, MongoDB, as well as obviously Cosmos, which was in the other slide that we talked about. And then software as a service provider, so things like I've used Jira for some folks, I've used the Dynamics 365 connection, I've used Dynamics CRM, I've used the Office 365, which can help us get information about like our O365 calendars, security groups, emails, all those kind of things. Concur is a travel and expense system, so a lot of flexibility here. When I started talking on Azure Data Factory, I think 3 years ago, there were about 60 or so services. There's now over 90, I believe, or 85 at least 85, I think. So there's the concept here is that third parties are coming in and working with the Azure Data Factory team to develop new connectors, and the team is producing connectors as well. So there's a bunch of things on that user voice site for Azure Data Factory for connectors that don't exist. So if you have one that you're using, maybe you're using Bamboo HR or Namely or something like that, definitely put that in as a feature request, right? Because the more feedback you give that feature, the more likely it is to get implemented. Hopefully, that's how it's supposed to work. I'm not sure if it works that way in practice. And then just more software as a service. So Salesforce, I've used that a bit. SAP. If anybody's ever worked with SAP, it's extremely difficult to get data in and out of that. So there's a connector there. Xero is another popular web-based accounting package. And then these are our compute activities. So Azure Databricks, right, allows us to run notebooks. Data Lake Analytics allows us to use SQL scripts. Azure Data Factory, that's probably the go-to way to do things. If you can't do it natively in Azure Data Factory, or if the solution becomes really ugly because of hoops you have to jump around, you can always go into an Azure function and you can write code in C# or PowerShell or Python. There's a lot of different supported languages. And what it allows you to do is, let's say I need to do some very complex logic to determine if I need to, what files I need to process. I could write an Azure function that goes in, talks to my data lake, gets a list of the files, use C# to iterate through there and figure out which files to process, and then return that result set back to ADF, right? Now, I could do that with a get metadata activity, but in some cases, if that logic is very complex, it can be very hard to implement, or it can become very difficult to test or debug. So a lot of people just by default will punt and use an Azure function for those kind of things. If I need to do any kind of other compute, like call a REST service that I can't generate a REST token for, I could stub that out with an Azure function and call it that way. I've also seen people call logic apps using webhook activities and things. So there's a lot of different ways to execute things to work around issues in ADF or places where they're not. So this just shows you there's a lot of connectors, right? Templates, so basically just a way to quick start with code. So the idea is that there's a template gallery. You can create custom templates, but you have to be connected to a GitHub repo, and everybody that's going to use your templates has to be in that same GitHub repo. So it's not an ideal solution right now. Microsoft does have a template gallery of a bunch of really good quick starts that they've already published, where the code is like, oh, I'm going to load an SCD type 2, right? So I can go download that template and it parameterizes everything out for me. So it's kind of nice. The problem with that is you can't currently contribute your own templates back into that gallery. So it's you get what you get and you don't throw a fit. I don't know. So here's an example of some of the older templates that they had, right? So if I needed just a pattern to copy data from Amazon S3 to Azure Data Lake Store, I could start with this pipeline template. It's going to give me a template that's parameterized. I can either hard code my values or I can make a dynamic pipeline from that, okay? So it kind of also shows you kind of some of the things that they do. Now, not all of these are indicative of best practices. So sometimes it just shows you, demonstrates a concept, but it doesn't have robust logging or erroring or auditing or things like that. So that's stuff you may have to bake on your own. Okay, so triggers, that's how we schedule. So think of a trigger as our way to do SQL agent type scheduling. That would be a schedule-based trigger. We also have tumbling window, which is, I wouldn't say it's deprecated, but it's more with Azure Data Factory V1 pipelines and not used so much with the Azure Data Factory V2 pipelines. And then event-based triggers. So those are useful when you want to execute a pipeline when a file arrives, for example. So I can watch a blob store file URL, or I can watch an actual file location. And I can trigger whether it was added or deleted. And we'll talk more about scheduling triggers at the end of the session as well. So integration runtimes, I've spent a lot of time talking about those. This is where the compute executes from, or where the queries get dispatched from. So there's 3 types. There's a public, which you get by default. That interacts with any of my publicly addressable Azure services. So Azure SQL Database, Azure SQL DW. Azure picks it. They dynamically at runtime figure out what region to use the runtime in. So it's the most efficient way to do it. You also have self-hosted integration runtimes. Those are when you have an on-premise or a private network. So it's behind a firewall or a VPN that you need to connect to. you install a self-hosted integration runtime, and that's what opens up the connectivity to the on-prem type servers. So SQL Server, Oracle, those kind of things. Then the Azure SSIS runtime is what allows us to run an Azure SSIS, or sorry, a SQL Server integration services package inside from Azure Data Factory. And what it requires is that you specify a reporting server catalog, or sorry, a integration services catalog, and the compute profile. So how big do you want the VMs to be? How many of them do you want? It controls all that, and you can start and stop those. So one of the key things to keep in mind is you are billed with those as they run. So if you're not using it, if you're going to execute SSIS packages once a night, then what I'd recommend, this is kind of a pattern, is the first thing of your pipeline should be to start the packet or start the integration runtime, wait until it's started, and then execute your packages and then shut it down. And that minimizes your costs for that, okay? So with that, just a little bit more. So this is the public integration runtime configuration. Now, this is kind of new. So with data flow, if you're gonna run data flows, you have to tell it what kind of Databricks compute you wanna do. So there's three types. There's general purpose, compute optimized, and memory optimized. You have core counts. You can go anywhere from 4 to 256 cores. It's important to understand that in Databricks, there's this concept of a driver node, which is where all your code kind of runs from. It's kind of the brain. And then you have executor nodes, which are where the work actually gets done when you have an RDD or a data frame or some kind of structure. And then time to live is important, because what will happen is if I spin up a data flow, this data flow runtime, if I don't put a time to live on it, once it goes dormant, it's just going to continue to run. So here I've got it set to 0 minutes. So as soon as it's not doing anything, it'll automatically shut down. And there's the fine prints down here if you want to read about this. So this is something that's important to make sure that you're monitoring. So I would set the time to live on it, but I would also monitor it, because you never know when things go bump in the night, right? And the last thing you want to do is get a $16,000 Azure bill at the end of the night because you left a data flow runtime running for the entire month, and all you were doing was doing a proof of concept to load some taxi data, right? That's not a good look. So self-hosted runtime, what you basically get is a pair of keys. You install a client software. It's very similar to the Power BI data gateway, right? You link those keys up. You have SSL encrypted connections into that gateway or into that integration runtime, and all the activity runs. It keeps itself automatically updated, or it can be configured to automatically update. And then it can be in a high availability and high performance mode. So what that means is I can have up to 4 of these in a single integration runtime cluster. So if one of those dies, it'll move the next workload over to another integration runtime. So let's say it patches because of Windows Update and the machine reboots. That pipeline will continue to run. You may have to catch that failure and resubmit that pipeline, but if it was in a for each loop or something, other activities are going to continue to run on other nodes. But it's also smart enough to say, hey, I've got 4 nodes. I'm going to send 4 queries to node 1, and 4 queries to node 2, and 4 queries to node 3, and 4 queries to node 4. It's not super intelligent. As far as I know, it's kind of round robin. So if it sees that I need to do 10 copy activities, it'll equally balance those across the available nodes. The SSIS integration runtime, so there's some settings here we talked about. You need to define a catalog, a database endpoint with an admin server. What's the performance tier of that database? And then the location of the VM that you're going to run. What's the footprint? So is it a standard D4? There's lots of different options. I would stay away from the A footprint ones. With the D3, the DV3s, I think this is an older screenshot, but I think those are the ones to use. And then you can see how, okay, I've got 1 core and roughly about 4 gigs of RAM, or I can do 8, or I can do 28, right? So I got to pick the RAM. How many nodes? In this case, I'm doing 2. That's probably not what you want, but it can do SSIS scale out. So if you have a lot of packages, like 1,000 packages, it'll do SSIS scale out. And then what license do you want to use, enterprise or standard, basically? This is just a diagram of kind of some of the scenarios. So I'm not going to spend a bunch of time on this. Just know that if you want to run SSIS packages, you have to create an Azure SSIS integration runtime. If you want to connect to things on a Azure Virtual Network or any of the Azure Platform as a Service offerings, I've got to use a if I want to connect to anything that's on an on-premise network, whether that's a VM or if it's stuff that's in a VNet, I need to use a self-hosted integration runtime. If I need to connect to an Azure PaaS service, I can use an Azure integration runtime that gets created for me by default. Okay, and it's also important to understand that it's only the data, the command dispatch that's coming from the factory itself. So it makes no difference if your data factory is in Southeast 2, but your data sources are in West US 2. As long as that integration is in West US 2, there's no data movement back to Southeast. Okay. And we'll talk about that here in this security slide. So this is showing that we're using port 443, so it's secure. So as long as your organization's firewall lets in SSL traffic, Azure Data Factory will be able to make that secured connection. That connection's encrypted by those two keys that I showed you on that self-hosted integration runtime. And then the data flows between the various data stores here into the integration runtime across the data channel, which is also encrypted, into the service in Azure, whether that's SQL DB, IaaS storage, or whatever. Okay. When I connect to resources in Azure, it's important to understand different types of authentication. So in an on-premise environment, I can use SQL authentication or I can use a Windows authentication. I generally recommend Windows authentication. It's a little bit more persnickety to get it working, but it's much more secure because you're not managing that credential itself, and it does more advanced kind of encryption. The concept of a service account exists in Azure. So this is a service identity. So in this case, the Azure Data Factory, so ADF V2 Demo Factory, has its own ID in Azure Active Directory, which basically means that I can assign rights inside SQL databases and inside Azure Data Lake Gen 2 to this demo data factory. So I don't need to manage a password. That's what the best thing about this is. Nobody can usurp this identity and use it to gain access, right? So if I can't do a managed service identity, then I'd fall back to a service principal. So a service principal is an application registration, and you basically create this in the Azure Active Directory blade. You create an application ID, which has a link to the tenant, and it also has a set of keys that you create. And then it has this name. So in this case, my service principal name is ADF DPSP. I can also assign permissions to that. So it's kind of like a service account, right? But instead of using a password, I use a key to authenticate, and the key just goes in just like a password would. Now, what makes managed service identity better than this is that there's no key to manage, right? Now, if I'm going to use service principal to say connect to blob storage, I would want to put that key in Key Vault, which we'll talk about here in a second to make sure it's secure, right? So Key Vault, Azure Key Vault enables secure storage of your secrets, such as passwords, or if you think server names are sensitive, we could debate about that, but it allows you to store those securely in Key Vault and retrieve them dynamically at runtime. So the ADF identity has access to the Key Vault. You tell it what secret name it wants to use. So let's say it's Oracle password, right? And everybody knows the Oracle password is Scott Tiger, right? But we'll store that in Azure Key Vault, and we can retrieve that at runtime and make sure that we're not storing any secrets inside the data factory itself. Now, if I did use SQL authentication and put the username and password in the link service, it's going to encrypt it, right? So it'll store it encrypted in the link server. So it's relatively secure, but it's not as secure as putting it in a third-party Key Vault service, okay, or a Key Vault service. The other benefit of Key Vault is other Azure applications can leverage that password, right? So you don't need to have 6 different locations where you're storing that password. It's just stored in the Key Vault, and I can use my other applications can connect to Key Vault to get that identity. So this is an example of creating a Key Vault link services, and here you see I'm creating a SQL DW connection string. So I don't use, there's no password in here. I just say the name of the secret is this. As long as the ADF has access to that secret, it can retrieve the password. Okay. So to kind of sum it up, that's our kind of whirlwind tour of ADF. I've got a lot of similarities, right? So I've got a lot of equivalents here, but a lot of differences as well, right? So the key, in my mind, the key differences are, ADF can be loosely bound to metadata, whereas SSIS is tightly bound. ADF does support a good deal of parameterization and dynamicness, but SSIS, you can put expressions on everything, so it's a little bit more robust. There's no local development experience for Azure Data Factory. It's just a web UI. And the SSIS, you pay for a license and then the compute that it runs on, whereas ADF, you're going to pay for the usage. So every time you're running pipelines, you're going to run up a bill. Now, the per pipeline execution isn't that much, but in some cases, if you don't follow best practices, you can rack up a pretty significant bill. Okay, so before we get into the design patterns, I want to bring back my slide, go to present mode. Let's see where we're at here. Oh, come on. All right, so we stabilize there. We got 29 responses, so most of you guys are asleep at the wheel. So let's see, is anyone here kind of currently using data flows? That's one of the questions I want to ask. I'll give you guys some time for that. So I work as a practice lead for a consulting company. We generally don't do a lot of data flow development. We tend to use Databricks, but that's changing because it's seeming to me that the mapping data flows are becoming a little bit more production ready and a little bit more fit to doing some of the things that we need to do. So I think we're going to start looking at those a lot heavily over the next year or so and start developing some patterns for using those. We typically use just the data orchestration of Azure Data Factory. So, and this is what I would expect. Actually, pretty close to what I thought. It's kind of interesting to me just to get this metric, and then I'll advance to this other one. But I'm just curious how many of you people are moving from SSIS, and if you're going to just migrate. So I've got 100 packages. I'm just going to move those to ADF pipelines. So I'm going to do kind of a conversion. How many people are going to keep some of that SSIS around and either run it on a VM or run it in from Azure ADF? I'm just kind of curious of what folks are doing there. So we typically see a lot of conversions from SSIS to ADF. We find that, so here's an example, kind of anonymous use case. I did some work for a client. They have maybe 100 SSIS packages. We were able to convert that into about 12 pipelines because it's so dynamic, right? Now we had to rewrite some of the logic, right? And if there's complex transformations, sometimes it doesn't always work out that smoothly, but in general, we were able to do everything. But these are traditional SSIS packages where you're primarily just orchestrating stored procedures, or your data flows are very simple with limited transformation in it. So it's interesting that there's not a huge uptake on the SSIS integration runtime. Now, if you are using Azure SSIS and you want to unlock some of the capabilities, so you're still using SSIS, but I need to talk to Azure Data Stores, there's the Azure Feature Pack, and they've just updated that for Visual Studio 2019, or not just updated it, but it's been updated for Visual Studio 2019. So those allow components to dynamically create H3 Insight clusters, connect to blob data, Azure Data Lake Gen 2, all those kind of connectors, and do some other things like manage resources and stuff. So those are definitely worth taking a look at. So with that, that's the end of the polls for now. Thanks everybody for participating. So let's talk about the meat and potatoes here of what we're trying to discuss, which is design patterns. So design patterns, they're reusable solutions for common problems, right? So I don't want to reinvent the wheel each time I do something. And I want to make sure that what I'm doing reasonably aligns with best practices, right? So these are things I can do. Sometimes they're not completely like, oh, I just use this design pattern and it's all done. Like I've got to take that design pattern and I've got to do some additional work to actually make it do something useful, okay? Why should you use these? It's pretty obvious to me, but they're tested patterns, they're proven, they're documented, right? So an example of a design pattern from the BI world might be a slowly changing dimension type 2, right? So if I say we're going to build a pipeline that builds an SCD type 2, everybody kind of understands that I'm going to have a begin and end effective date in his current flag, and I'm going to perform SQL logic to perform that data transformation, okay? So today we're just going to cover basic load patterns, so what I'd call staging patterns. I do a full day kind of pre-con version of this where I cover data warehouse loading patterns, so loading periodic snapshots, handling SCD type 2, type 6, type 4, all the different various flavors, as well as how to handle like file processing. We just don't have time to get into all that, mainly because I spent most of the time talking about a bunch of crazy ADF basics, right? But we're going to cover four basic patterns, but these patterns are the foundation of what gets you to where you need to be so that you can start building those data warehousing type patterns. So the first one we're going to look at is a full extract. So that's a truncate and load. I'm going to use this when I need to move all the data over. I can't use replication in this case, right? So if I can use replication, I might consider that. I have small data sets that change often, and I have no historical requirements. So this is a pretty naive approach. It's also known as kind of like the one-shot data warehouse, but sometimes this meets the needs. If your customers or your organization doesn't need type 2 tracking, this might work well enough, right? So what does it look like? I've got a source, I've got a sink, I use a copy activity, and I'm copying from an on-prem SQL server into an Azure SQL DB, okay? So here I'm using pipeline parameters to say, here's my source reader query, so select star from customer. Here's my pre-copy script. I'm gonna truncate the table before I load it. I'm gonna use batches of size 1,000. Ignore the proc name and proc type for the moment. That's not part of this pattern, or those parameters aren't used as part of this pattern. But I'm using those pipeline parameters. Here I'm passing in the table name to the data set. So I've got a dynamic data set, so I can tell it to tackle any table I want. There's no explicit schema mapping here. My sink has a couple parameters. So it's got a table name, where do I want to go? What's my pre-copy script, right? So I'm dynamically generating that truncate statement, and I'm controlling that write batch size. So because a common misconception in ETL is rows equate size. That's not always true, right? So I could have a billion row table that's smaller than a million row table if that billion row table is very narrow. Maybe it only has 6 columns and they're all integers, whereas my million row table has a bunch of arcar maxes in it. So I can use this batch size to tune that parameter to kind of reduce the transaction log load on the destination source, whether that's a SQL database, which does a lot of transaction log governance. It's definitely an important parameter to be able to play with to get optimal performance. And then user properties, this is something that not a lot of people are familiar with. What this is I'm basically setting these properties. So I have batch ID, source, and destination. And then here you can see I'm using dynamic properties to set those up. So batch ID is something that I create in my ETL framework. Parameters, this is the parameters collection of the pipeline, source table name, and parameters sync table name. Those are all coming from the parameters collection of the pipeline. So those are input parameters. Now, what this gives me is named properties, batch ID, source, and destination that output to the log. So if you can imagine, if I'm doing a dynamic pipeline and I want to see which table did it fail on, if I have these user properties specified, I can actually output those in my log view, and I can actually see those values without having to like dig through the JSON, right? So it's very useful, and a lot of people don't use these. Another property that people don't use much of are annotations, which I think are fairly useful. It's a way of kind of classifying your different link service connections, okay? So that's a trunk and load, very simple pattern. So merge load is kind of an incremental load, but kind of not. So it's really just saying, I'm not going to overwrite the rows in the table, but I am going to incrementally write it, but I still have to pull all the rows from the source. So it's not optimal, but it's better than just doing a truncate and load. But it doesn't solve the only give me the changes, right? And so what this involves is using a stored procedure and a table type as a DTO to move the data from the source table to the sync table. And so what the configuration for this looks like is I have my same source configuration, right? This is my query. Now notice what I'm doing here. I'm selecting all the rows from the customer table, and I'm creating this hash statement. Now for those of you guys that aren't familiar with that, that statement will basically concatenate the values of the columns that are changing, and I can compare that hash with the previously stored hash to see if there's a difference. So I use the primary key to determine is it new or existing, and I use the hash statement to determine if it's updated or deleted. I could also use a bunch of where statements, right, where this isn't equal to that, and so on and so forth. But this hash bytes, I think, is more efficient and elegant, okay? There's some caveats that apply with that, which we'll look at in a minute. So The sync activity has a difference. So now all of a sudden I'm calling a stored procedure, right? I'm using the sync table type, which we'll look at in a minute. And then I've got my parameter or my batch size parameter still there. Okay, so the table type is just using a standard SQL Server table type. Okay, I've declared a primary clustered key on that for customer ID, so I don't want to get dupes, right? Row set, this row set exactly matches what's coming in from my source query. That's a key thing. The ordering, the casing of these columns and the data types all need to match up for the magic to happen. Otherwise, it just breaks. Now I've got a stored procedure that I call, and what happens is, so if my batch size is 10,000 and I'm hitting a 100,000 row table, I'm going to call that 10 times, and I'm going to send in a fully populated source data set here of that customer type. It's read only, and I can pass in additional parameters. But now what this gives me is the ability to do transformation, right? So I'm using everybody's favorite ETL statement, the merge statement. There's a lot of hate for the merge statement. So if this offends you, by all means, knock yourself out and do an insert update and do it the hard way. But I found in my experience that merge works for smaller data sets, so up to about 1 million rows, maybe a little bit bigger. If you go larger than that, then yeah, some of the caveats apply. And the key thing here is I'm not updating the table that I'm querying from. So there's a lot of weird like concurrency bugs that come out with this, and duplicate reads and stuff when you're looping over the same table and trying to merge back into itself. But I'm not doing that here. I have a source table and then I have a destination table. So I'm querying from my source. I'm looking to see if the customer ID, target customer ID equals source customer ID. If it does, and the hash key is different, then I know it's an update. And so I'll just go overwrite all the fields. I'm also adding the update batch ID and the update date time to track that metadata of when it was updated. If it's not matched, then I can assume that it's an insert, right? So I'll insert. And you can see I'm adding the current timestamp as well as the updated timestamp. Notice I set those in pairs. So if I'm updating, I just update the updated one. But if I'm inserting it, I'm setting both the created and the modified date to be equivalent, just to make the future querying of that metadata more easy. Now notice what I can't do here. Unless I can do a full outer join and I have that full result set from the source, I can't detect deletes here. So that is a limitation of this. But if in a data warehouse, typically I don't need to detect deletes. Sometimes I do, but a lot of times I don't. So there's other patterns I can use to detect deletes, right? But the full outer join is really the best way to detect deletes in a SQL-based environment, right? So if we don't need to get into it, but basically that's the way I would go about that. So this is a little bit about hashing. So notice that hash key generates, even though these strings, the only difference in these strings are really about 4 characters. Well, there's the first name, and then I've encoded the null as a star here, but the strings are similar, right? But the hash is wildly different, and that's what you're looking for, right? So my recommendation is to use SHA-1. It's a 40-byte hash. It is deprecated from a security or encryption standpoint, but it is robust enough to handle data scenarios. I hear a lot of people complain and saying, hey, I tried using hash byte SHA-1 and it gave me hash collisions. So I had the same hash for different records. Almost always, when I dig into that, they either didn't encode the data correctly in the hash string, so they either didn't handle character conversions properly, so converting this datetime value to a string, or replacing nulls or blanks with a out-of-band delimiter, or they didn't concatenate all the fields that they expected to change. So, there was a change in the middle name field and they didn't add that as a concatenation here. So you've got to handle string conversions from non-string data types, and you've got to handle null conversions. And I always recommend to use these delimiters as well. And that input to that hash always has to be stable, meaning that you can't change the format of it because you've invalid all your stored hashes. The other way is to compute it on lookup when it comes out, and when it comes in, it's a little bit more difficult. And then a lot of people stop and they don't do this convert function, and then they get these really weird characters in their field. So I always recommend casting it to ncar 40. That's a little bit more tuned from a performance standpoint, and it's a little more friendly to look at in this format. And that format is because we're running it as a convert with option 2 here. Gives us this kind of GUID looking format, okay? So there's other things that don't work. So don't do checksum, don't do hash bytes with an MD5. MD5 will generate collisions, right? It's been proven. It's very easy to generate an MD5 collision. It's smaller, right? So by 4 characters, but the hash byte SHA-1 is significant. You could do SHA-2 or larger. I don't recommend it. It's a little bit more performance overhead. And then checksum is totally invalid for doing any kind of change detection in SQL Server. So disavow yourself of that opinion. And then here's my sync table. So all my customer fields. Notice I've got my ETL auditing fields, which we're going to talk about those more in detail. But the key one we need to look at is that change hash key. That this modified data is actually a modified data of the source system, and they're actually using RoGUID, which is a timestamp. That's the old SQL Server 2000 way of doing change detection, optimistic concurrency. Basically, that RoGUID updates every time a row is inserted or updated in the table. Again, I've got my user properties, right, useful for diagnostics. Now, if I need to do a true incremental load, I only have a few options available to me. I could use temporal tables, I could use triggers, I could potentially use a date time column or an integer column with an ascending key, or I could use engine features, right? So in this case, I'm going to show you guys what change tracking would look like. Now, there's certain tables like periodic snapshot, I could totally use like a high watermark for. But for most delta detection, I've got to go with change tracking. What I'm going to do is change tracking is going to give me the watermark from the last iteration. I can store that value in my ETL control table, and then I have a query that'll go out and give the current version of the source database. So where's the change tracking at? Then I can take those and basically say, pull me all the changes since the last changes I pulled, and it'll just bring me the inserts, updates, and deletes. And then once I'm done loading those and doing my merge, I just update the watermark for the next run. Okay. As I mentioned before, you could do an ascending integer or date time value just by doing a select max from the column. But I don't like this approach because it assumes that the date's maintained automatically, so there's no backups, restores, there's no wild DBA going in there and running random update queries that are disabling triggers. It assumes the trigger logic is correct, right? It assumes a lot of things. So I'm not a huge fan of these. They can work for specific scenarios, but definitely double check it before you try to do this. Change tracking, it's a fairly lightweight solution. A lot of people have a bad opinion of it because it breaks down at like very high volume. But it's pretty good as far as telling me has a row changed, which rows have changed, what kind of change was it. It only tracks the last change. So if I pull it at 6 a.m., it's going to give me the current state of that record. So if I inserted the record and then in the interim updated it twice and then deleted it, I only get that final state of delete. I don't get those interim changes. So I need to enable change tracking in the database, enable it per table. I get the initial data and then I get changes. So alter database statement, I'm going to kind of try to speed up because I know I'm hitting time. I enable the change tracking at the table level, tracking columns updated. So that's a bitmask that can be used to determine which columns actually changed. I don't really use it much, but it's kind of default syntax. I can turn it off by disabling change tracking. And then my query looks like this. So I'm basically going to cross apply this internal function called change table. I'm going to specify the source table, the primary key attribute, and then I'm going to join it on these two. And then in the change table itself is aliased as C. It gets the system column, so it gives me syschange version. It gives me syschange operation, which I'm mapping to insert since this is my first time initial load, and then syschange context, which is that bitmap. Okay. Now, if I want to do it when I'm running, like so, I've got the ETL already going. I'm going to call that change table, passing in the table name, and also passing in what's the last version that I know about. So if I know about version 11 and the database is now at 19, then I tell it, I know about 11, give me everything up until 19 over here, the current sync version. Now, if the changes are out of date, meaning that it's been a week since I pulled the data and I'm not retaining a week's worth of changes, then it'll actually tell me that the last valid change value is 17 or something like that. In that case, that's my indication that I need to go do a full load. All right, so there's a little bit of complexity there with change tracking. I've got all these queries that I can run to get the data back, right? And then I store that information as an ETL high watermark ID in my control table, right? So those are some of the options. So here's some of the incremental table approaches. Now, this is really the meat and potatoes of building a dynamic solution. So in this case, up until now, I've done one table, but I've parameterized it so I can change the table names. But now I need to use some metadata to drive it. And what I can do is basically have an ETL control table that I iterate through using a for each loop, doing the lookup activity to get the metadata, and bringing the data from the source table dynamically using the table data type into it. And I can also create an audit log. Okay, so let's just really quick look at one of those, what that would look like. So here's the example of what it looks like. I get my current watermark, I get my last high watermark, I have my copy activity, and I have a stored procedure to update the watermark after its end. The rest of this copy data activity is very similar to what I showed you, right? So there's my source with the parameterization. Notice here I'm passing in the value from the lookup activity to get the last high watermark. So I'm generating that, so on and so forth. I can go back and kind of show you guys. Let's see. Let's do this merge load. There we go. So what that looks like, and then you'll notice, I don't know why the UI's, that's really strange. I think it's frozen up on me. All right, well, I'm gonna go back to the slide deck, sorry. All right, so a couple of things, the auditing from a logging standpoint. So every ETL process should have what's called a batch ID. Batches are logical concepts, and they're just used to group the load together, right? And then the batch has a terminal state, so it either closes when the batch either fails or succeeds, okay? And so in this case, I can generate the batch ID using a sequence operator or using a GUID or something like that, but I'm passing it into the pipeline so that every ETL process that I do is going to have this batch ID associated with it. I'm also going to have common audit columns. So I'm going to have a created date, a created batch ID, modified date and modified batch, and then is deleted if I want to track soft deletes. Okay. So, but these tables tell me when it was updated, when it was inserted, when it was updated, if it was updated, and then which batch ID. And if I store that batch ID in my audit log, then I can go back and see when that, I can see other metadata about that process, right? And so this is what my audit log would look like. I've got my batch ID as my primary key, and then I've got what's the source system, what's the pipeline name, what's the source name, what's the sync name, how many rows were inserted, how many rows were updated, when did the ETL start, when did the ETL end, what was the duration in seconds, if there was an error message, and did the load finish successful or not, right? So I've got all that metadata. That's a custom log that I create. Now, ADF will log its own execution, so you can log it to various different sources, but I find this to be more customizable, right? So I'll insert and update these log entries with stored procedure calls before and after the copy activities. So there's lots of other patterns, but we don't have time because I'm horribly over time. So kind of some key takeaways here is, make composable single purpose pipelines. So one of the key mistakes I see people making is they have a for each activity, and inside the body of that for each activity, they have 10 activities nested in there. I would refactor that out into a pipeline and call that pipeline from within the for each, right? So that way I can run the pipeline independent of the driver loop and play with it and test it. You're definitely going to want to leverage parameters and variables, right? So variables mutate, parameters do not. And user properties helps with my auditing and logging. And the key thing that enables dynamic behavior in your pipelines is the lookup activity, which allows me to get data from my control table, my for each, which allows me to iterate over it, and my metadata activity and my validate activity allow me to validate that data is there and it's in the right format. The key thing to building any kind of dynamic ETL process is ensure your metadata is modeled correctly, right? So in the latest version of my ETL framework, I store all my metadata as JSON and I shred it out. In some cases, you can't make Azure Data Factory dynamic because it doesn't support the dynamic properties natively. So in those cases, you can sometimes you can have success by hacking the JSON file directly and editing the expression in there. You gotta be careful of that. And this is another thing, and I didn't hit on this, and I really should. pay attention to cost and pricing. So you want to avoid patterns where you're calling activities in a loop that you could do once, right? So rather than getting a list of tables and then looking the metadata up inside of a for each, I'm going to get the list of tables and the metadata in one call, and that's going to save costs. The other thing too is to make sure that you're setting timeouts and data integration runtime units at the right level for the resources. So by default, Auto will give you 4 DIUs, which generally aren't necessary in most of your copy activities if you're going into a SQL source, and definitely not needed in a lookup activity. The other thing too is timeouts. I've seen Databricks notebook jobs hang for like the weekend. You get billed for that entire time. Even if that Databricks job terminates, ADF still thinks it's running. So you get billed for ADF consumption. So the default timeout on an ADF pipeline activity is like 7 hours or 7 days, I'm sorry. So set it to something reasonable. Like in my mind, if something takes longer than an hour, an individual step in my ETL, I don't even want it to finish. I'd rather just kill it and I'd go in there and I'd tune it because it's probably something went bad somewhere, right? Now you might not be that dogmatic about it. You might say, well, 2 hours, we have some stuff that takes 3 hours. But in my mind, like once it kind of flips that bit and goes, it's hung, right? It's not coming back, and it's probably doing something stupid like a cross join or who knows, right? Maybe it's just fell asleep on us. So pay attention to cost and pricing. So not only set those fail-safe parameters, set logging and alerting up to catch long-running pipelines, right? So any pipeline that's been executing for more than 3 hours, alert on it, right? Send somebody an email, because I've seen it 5 or 6 times in the last year where we've had developers kick a full load off in our development environment, and they come back Monday morning and the thing's still running. So that can get expensive. So we're going to bang through this. So the best practice is to configure a source control repository. You have to use Git repositories. You can either use Azure DevOps or GitHub. What that does is it allows us to save data in a source control repository. So this is just showing you that you have a choice here. It's obviously an old screenshot. I can configure the name of the team services or the Azure DevOps account, the project name, and then the repository within it. It has this concept of a collaboration branch. That's the only branch that can publish to your data factory. So the problem with being in live mode, which is where I don't have a source control repository, is that I have no ability to save interim work that isn't in a working state. If the pipeline doesn't validate, I can't publish it, and therefore I'm blocked. So as soon as I hook up source control, I can save those non-validating pipelines and activities and kind of do more incremental work. So there's a whole recommended Azure DevOps flow to this. So we're running kind of short on time. I always recommend, if you're working in a team, you create your own branch off the master branch. You make your changes there, and then you do a pull request back into the master. This is just kind of showing that workflow. This is the older version of it. The UI looks a little bit different, and it'll change based on whether it's GitHub or Azure DevOps. But the idea is that I am a big fan of squashing changes. So if I do 6 commits in my branch, when I go to do the pull request, I just want to see one final commit in the master branch. And I want to delete my branch after I'm done. I don't want to have long-lived branches. ARM templates is another way. So I can export an ARM template that represents the current state of my data factory. I've got to do it through the UI currently. There's no support to script that, either via the REST API or a PowerShell commandlet, which is very unfortunate. This template, I can deploy that via a PowerShell script, or I can deploy it via the portal UI. It has a parameters file, so everything gets hyperparameterized, and then it has a template file. This is my feedback item. I think this one has almost 100 votes now, so definitely go upvote this. I think it's hugely important to have a PowerShell admin surface for Azure Data Factory. The one they have right now is pretty poor, to be honest with you. I think there's a lot of scenarios to use PowerShell to generate code, and I think there's a lot of scenarios to use PowerShell as a way to do DevOps outside of Azure DevOps, or to do different things with it. So I think this commandlet or this support is important. You may not, don't really care. CI/CD DevOps. So we've got our stuff in Git. We've got our development ADF is hooked to version control. However, our test and our prod are not hooked to version control. So what would happen is we would basically create an Azure DevOps pipeline that says, when I'm ready to publish to production or to test, let's say test is my first hop, I'm going to do a build in Azure DevOps, and then I'm going to do a release, and that release is going to go to test. I'm not going to ever make any changes in my test data factory or my production data factory. If I find a bug, I'm going to go back into dev, fix it in dev, and push it into test. Just last week, there was a really great presentation on CI/CD training by the Data Factory team. It's up on YouTube. If you just Google CI/CD training for Azure Data Factory, it's about an hour long. It covers this whole process in depth. It's not as complicated as this diagram makes it look. It's very basic, especially if you understand Git and Azure DevOps. There's also another member of the community, Camille, has a YouTube video on this. So if you Google this, Azure Data Factory Continuous Integration and Deployment with Azure DevOps, he's got a great video that walks you through this step by step. So this one that Dan did is a little quicker and cuts through it. Camille's is a little bit more in depth. And I think there's some other ones out there. There's other folks that are talking about this. I have a talk on it as well. So logging, so a lot of things to configure here. I can log to a storage account. I can send it to an event hub, or I can send it to log analytics. I can choose what I want to log and how long I want to retain it to, and I can also log metrics. Very useful. These are just the JSON schemas. This is all from the docs, so it's probably a little bit out of date, but just for reference purposes. Metrics, so did the pipeline succeed? Did the activity succeed? Did the trigger succeed? Did the trigger fail? I can basically set up alerts on these metrics to determine, should I restart the pipeline, right? There is some monitoring built in, so I can monitor the integration runtimes themselves, so I can get information on a self-hosted runtime about the available memory, the CPU usage, whether it's patched or not, so I can pull those metrics from there. This is an example of what that looks like from the portal. There's also a PowerShell API for doing this. This is extremely useful to see, is your Azure SSIS node correctly sized, right? It'll give me available memory, CPU utilization, and how many concurrent jobs are currently running, okay? Azure Data Factory Analytics Preview, this was a dashboard. I don't know if they're maintaining this. Sorry, the screenshot's kind of crappy here, but it just gives you basically some basic ETL metrics on your pipelines. Definitely go check it out. It's not great. I've built a lot of Power BI dashboards around my ETL framework that show me, like from a business standpoint, like which processes, which source systems failed. I also have data quality reports that tell me, here's how many rows I corrected, here's how many bad rows, here's how many I rejected, those kind of things. Which you can't get out of the default logging. You have to kind of decorate that logging with your own custom behavior. As far as alerting, I can set up alerts from within Azure Data Factory from this alerts and metrics tabs. I can also do it from the Azure portal by going to Azure Monitor. The Azure Monitor experience is a little bit more robust and full featured. The alerts and metrics experience here is, I'd say, a little bit simplified. They both work the same. You just have more capabilities and features from here, okay? Session resources. So I've got some links up. I'll put some more over the next couple days. I kind of ran out of time this morning. But if you go to bit.ly/Azure Data Factory resources, that'll redirect you to a GIST that I have on GitHub that has links to the resources from this session, as well as some just generic resources. Azure Data Factory documentation is pretty good when they update it. Request a feature. I've requested a lot of stuff. Some of it's gotten done, some of it hasn't. So I definitely recommend getting feedback into the team on this and upvoting things that you think are useful. Updates. So there's this might be out of date. So this is the overall Azure release channel. I think the team now has a new technical communities blog. I'll go track that URL down for you guys, and I'll put it in my resources as well. Just a little bit of a rant here. They don't always do a great job about telling you that features have changed or the UI has changed. Generally they do, but a lot of times little things kind of slip through. So it's super frustrating to train on this because a lot of times I'll be looking for something that's been moved, or like last week we found that they released functionality to add columns to a copy activity from like file metadata or expressions, which you couldn't do previous to that. And it just kind of shows up. And the good thing was they documented it. The bad thing is it didn't look like they released it anywhere, right? They didn't do a formal release saying, hey, we added this great new functionality. So a lot of times if I don't work with ADF for a couple weeks, I'll come back in and something will have a new icon, or there'll be new positions or whatever. So they definitely product management gaslight you a lot to like thinking that you're crazy and you don't know where stuff is. It's very confusing. That's all I've got. So thanks for everybody who made it with us. hopefully it was useful. Definitely send Jason any feedback you have on this. Send me questions. I would say that if you want to see me dive into any other topics on Azure Data Factory, let me know. I've got a full day of training on this that covers SSIS, covers data flows, covers more design patterns. So I've got a lot more content I can share with you guys.
All right, excellent, Jason. Thank you. So we do have a number of questions, and I think the easiest thing will be that why don't I send all the questions over to you, and if you want to put together some responses, and then either send me back the Excel, and I can publish that with the meeting notes, or I can, or you can put that up on your blog and then send me a link, and I can send that out to everyone.
Okay. Yeah, and if you guys get those questions in, and if you guys want to email me questions, I'll endeavor to get that done by tomorrow morning. So I'll get that information. I'll answer the questions that I can. I'll send it over to Jason, and then I'll post it on that resources page as well, so you guys have access to it. So yeah, I apologize. I know I went a little bit long. Hopefully, I also probably went wrong, but hopefully it was good content for everybody. So hope everybody got something out of it. So thanks.
All right. Excellent. And thanks everyone for joining. Thank you again, Jason, and we'll talk to you next time.
Yep. Bye.
All right. Bye.